In last class, we are discussing about types of random variables. Mainly, we are discussing three types of random variables in our subject. Those are discrete random variables, Already we are seeing that a definition for a discrete random variable. We can take in that discrete values in a finite interval is calling a discrete random variable. For example, we have to see that some of the examples like a dice and counts, etc. In this one, we have to rolling a die. What are the outcomes we are observing when out rolling a die? Rolling a die, we have to totally 6 outcomes. We can observe that. Those are 1, 2, 3, 4, 5, 6. Each outcome is 1, 2, 3, 4, 5, 6. These 6 outcomes is a total possible outcomes when out rolling a dice. Here we can getting the any one of the outcome is suppose we can take in that the achievement of a 2, the probability we can find that the 2 achievement possibility is only 1. Then you can write in that is a 1 divided by the total possible outcomes are 6. This one is the probability for getting the 2 is our desired outcome. Here the representation for a discrete random variable, we have to mention that the outcomes in terms of numerical values, the discrete values. The second one is continuous random variable. In continuous random variable, already we have to some discussion about this continuous random variable. That one is we have to take that infinite values in a finite interval. Infinite values in a finite interval, you can call in this one is a continuous random variables. For example of this continuous random variable is blood pressure and weight. These are a time to changing. That's why these two are considered as a examples for continuous random variable. In last class, we are saying that the discrete random variable is obtaining on a continuous sample space. Continuous sample space. But here the major difference, the discrete and continuous is the continuous random variable is not obtaining on discrete sample space. Discrete sample space. It is not possible. The third one is a mixed random variables. Already the name is indicating it's a mixed random variable. The mixed random variable is a combination of discrete random variables and continuous random variables. For example, we can take in that example of the discrete random variable is we can take in that at a time 2 events that these belongs to mixed random variable. One is a continuous random variable and the second one is a discrete random variable. The continuous random variable, we can take a spin wheel. It is marked from 1 to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. This one is the example for continuous random variable. At the same time, we can take in that the rolling a die. The rolling a die is having the numbers 1, 2, 3, 4, 5 and 6. At that time, when performing these two events, we are getting the some pairs of combinations. Those combinations we are calling, those cases only we are using this mixed random variable. Coming to next one, some of the examples. The first example, consider a random experiment of tossing a coin twice and a sample space is. Here, in this example, we will consider the 2 coins. We are tossing these 2 coins. What are the possible outcomes is available when to performing this event? Here we are mainly consider the 2 coins, 1, 2. These are tossing the simultaneously. The outcomes are the pairs is head head, head tail, tail head, and both are tails. In this case, what are the possible outcomes is available in this experiment? Those outcomes we are assigning to some discrete values. Those discrete values are defining based on our requirement. The requirement is define the random variable x as the number of heads in the experiment. In this experiment, how many number of heads can be existing when after tossing the two coins? The first case is both are tails. You can assign it to 0 value. The second combination is only single head appearance. In single head appearance is a event is tail head. And third one is also belongs to single head. This one. Here also can assign that value is 1. And fourth one is it is having the appearance of two heads. The two heads we can assign to one number. The number is 2. Finally, we can representing these assigning values. These assigning values into a function. The function we are calling a discrete random variable capital X is equal to values are 0, 1, 2. This one is a representation for a discrete random variable. See for another example for a discrete random variable rolling a die. In this rolling a die, we are having that random variables x is having the events is 1, 2, 3, 4, 5, 6. These we can representing x of j is equal to j. The j value is varying from 1 to 6. The process is rolling that. Rolling the values can be displaying in a discrete orientation. That's why is also one of the example for discrete random variable. This one is a graphical representation. When after rolling a die, the possibility of each event can be represented in a graphical orientation. Here, each event can be presenting the probabilities 1 by 6. Here, we are writing the sample space is S is equal to 1, 2, 3, 4, 5, 6. For getting the 1, the probability is only the event occurrence is 1 chance, 1 divided by the total possible outcomes are 6. For getting the 1, for getting the 2, the probability, now we can take in that the chance is 1. That's why you can write in it 1 divided by 6. 1 divided by 6. Now you can see the for getting the 3. The 3 event is only one time. Only one time. The desired outcome is one time divided by the total possible outcomes are 6. This is the probability. Similarly, you can writing for getting the 4, 5 and 6 is also having the corresponding probability is 1 divided by 6. Its magnitude can be represented graphically. Here x is representing the event and p of x is representing the corresponding probability. We can add in this all values. 1 by 6 plus 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 1 by 6. The complete value is getting the 1. This is a graphical representation for when out rolling a die. Already you have to see some of the examples belongs to discrete random variable and continuous random variable and a mixed random variable. But when out to giving any problem, how to simplifying that? Suppose we can take in that tossing a 3 coins. Tossing a 3 coins. What is the sample space values? The sample space values are we are writing in terms of the possible outcomes. S is equal to the outcomes are first all tails. Tail, tail, tail. Next you can write in that tail, tail, head. Next tail, head, tail. Next you can write in that head, tail, tail. Next we can take in the two heads, head, head, tail, head, tail, head, next tail, head, head. Next possibility is all heads. This one is one of the example for discrete random variable. Here also your desired outcome is getting the head. Getting the head for this random variable. For getting the head, you can take in the combination of all t's. There is no head is presenting, we can take in the 0. Here in this case 1. Here in this case is also be one head is presenting. In this fourth case also one head is presenting. In second one, the presenting of number of heads are 2. Here also be 2. Here also be 2. In last case, the number of heads are 3. Finally, the random variable we can representing capital X is equal to, we are giving this 0 and 1 and 2, 3. These are the events. This total X can be represented in the discrete random variable. Discrete random. What is the probability that you roll a die? Given data is the die is rolling. Die rolling. Die is rolling. Here the required value is 3 or less. 3 or less. 3 or less means the value must be equal to 3 or less than 3. Equal to 3, less than 3. This is our requirement. Equal to 3 and less than 3. Less than 3. We can write the sample space S is equal to the total possible outcomes. 1, 2, 3, 4, 5, 6. These are the total possible outcomes. From this one, we can getting the equal to 3 or less than 3. For this one, we are writing the probability. The probability of capital X value is less than or equal to 3. This is a requirement. According to given data, he is asking that we can find the value is equal to 3 or less than 3. Here, equal to 3 or less than 3. What is the possibilities is there in this event? You can write in the probability of values are at 1, 2, 3. Only 3 events is presenting. We can write in that probability at X is equal to 1 plus at probability at X is equal to 2 plus probability at X is equal to 3. Here, for getting the 1, the probability already we are discussing in last section. That is, for getting the 1, the probability is probability of X is equal to 1. We can get in this one. For achieving one value when after rolling a die, the probability you can writing is a 1 divided by the total possible outcomes are 6. Similarly, for getting the 2, we can write in the probability of capital X is equal to 2, that is equal to 1 by 6. And finally, for getting the 3, you can write in the probability capital X is equal to 3, that is equal to 1 divided by 6. Only can achieving the 3, chance is 1. The total possible outcomes are 6. Each and every element appearance probability is 1 by 6. Just you can take in the all values and you can put in this relation, you can find the probability. That is 1 by 6 plus 1 by 6 plus 1 by 6. LCM is 6. Values are 1 plus 1 plus 1. It is 3 by 6. And equal to is a 1 by 2. The next problem is, what is the probability that you roll a die? Here also there is a die. The dice. Will it die 5 or higher? 5. The value is exact 5 or higher. The same process. For doing this one, what is the given data? The outcome. You can get in the exact 5 or higher. For getting the, and after rolling the die, the possible outcomes are, we are writing as is equal to 1, 2, 3, 4, 5, 6. These are the total possible outcomes. In this case, our desired outcome is getting the 5 or higher than 5. For this one, you can writing the given statement in terms of probability. The probability of the value, the capital X, is equal to 5, higher than 5. It is greater than or equal to 5. From this given data, the total possible outcomes are 6. In this one, we can get in the 5 and higher than 5. Only the 2 events is there. That's why we can writing that the corresponding probabilities respectively. That is, you can writing that the probability of X is equal to 5 plus probability at X is equal to 6. Here you can find the individual execution for each and every event. For getting the 5, you can writing that the probability for getting the 5 value is X is equal to 5. The event occurrence is only chance is 1. You can writing that is a 1 divided by the total possible outcomes are 6. This one is the probability for getting the 5. Similarly, we can take in the probability for getting the 6 value. The successive chance is only the 1 chance. 1 divided by the total possible outcomes are 6. Is a 1 by 6. Now you can substituting these individual probabilities in above relation. That is a 1 by 6 plus 1 by 6. The final value is LCM is 6 is a 1 plus 1, that is 2 by 6 is equal to 1 by 3rd. Is the probability when after rolling a die you can getting the exact value is equal to 5 or higher than 5. This is the probability. Otherwise, you can take in that the complementary event. The complementary event is here greater than or equal to 5. Its complement is the value must be less than 5. Less than means except 5 remaining values you can consider, that is 1 minus. Already you know the property for getting the complement value probability. The probability of X complement is equal to 1 minus the probability of X. Probability of X. Based on this property, we are making the solution in another method. The method is a 1 for a sample space probability, and this event is representing exact complement for a desired outcome. The desired outcome, you can writing that 1 minus is a 2 by 3rd. The final value is a 1 by 3rd. In last class, we were discussing about the pack of 52 cards flowchart and what are the cards is available in a pack of 52. Today class, we have to see that some of the problems belongs to probability theory. First of all, what are the properties available in probability theory? We have to see that. After that, we can do some of the problems on probability theory. First, the properties, the available properties in probability theory. The first property is the axioms. The first axiom for probability is, you can take in that one event, the event is A. The event A, the probability is greater than or equal to 0. Greater than or equal to 0. And second axiom is the probability of sample space is equal to 1. Is equal to 1. The third axiom is you can consider two events. Those are A and B. Let us take in that two events, capital A and capital B. These two are not having any common element. These two are not having any common element. That's why we can take in that the intersection of these two events is equal to 0. Two events is equal to 0. According to probability summation formula, we are writing the probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Here the intersection part is 0. 0 means is a null set. Already we are having some discussion about null set. When I have to consider the probability for a null set, the value is a 0. That's why the probability of intersection element we can make into 0. After substituting the 0 value in this formula, we are writing that the probability of A plus probability of B. Coming to fourth one, the fourth one is the probability is always varying from its initial value and final value. The initial value is 0 and final value is 1. That's why I can representing the probability value 0 less than or equal to probability of one event is less than or equal to 1. Coming to fifth one, one have to take in that two events. One event is a normal event and second one is its complement event. These two events we are calling the sample space. Here you can take in that X, I am taking the one event, its complement we are writing the X complement. It's X plus X complement, we are calling that sample space. It is calling a sample space. Now you can take in the probability on both sides. We can writing this probability of X plus probability of X complement is equal to probability of S. Already you know that the probability of sample space, the value is 1. Now you can writing the complement or a complement for a X event. You are writing that the probability of X complement is equal to already the value is 1. That's you can writing that is 1 minus probability of X. Probability of X. When out to asking the complement events, we are using this formula. So having that a box is containing 16 red balls and 22 black balls and 12 green balls. This is our given data. From this given data is asking, you can pick one ball. The ball must be red color. Red color, what is the probability? And second one is, you can pick one ball. The ball is having combination either red or black. The ball is pick one ball. The ball is red or black. And third one is the pickup ball is neither red nor green. Neither red or nor green. According to from given data is asking mainly 3 points. The first point is, what is the first point? the pickup ball must be red color. And second one is the pickup ball red or black. And third one is neither red nor green. First one. What's the first one? The pickup ball must be red color. Already know that. When I want to find the probability, the fundamental definition is the desired outcome divided by the total possible outcomes. Here, how many red balls is available? Here the red ball pickupping event, we can consider one event, the symbol is A. The event A appearance probability, we are writing that as the probability of A. Here A is representing the, you can pick up the ball is a red color. The red color balls is available in this box is, how many available balls is there? The 16. 16 balls is available. 16 divided by the total possible outcomes. What is the total possible outcomes? We can make the summation between these. 16, 22 and 12. The total value is 16 plus 22 is 38. 38 plus 12 is 50. The sample space is having the 50. Here you can write in that is 16 divided by 50. For getting the ball is a red color, the probability is 16 divided by 50. Coming to second one. What is the second one? He is asking that the pickup ball red or black. Red or black. Here you can assign the red color event is A and the black color event is belongs to, you can assign the number, otherwise notation is B. According to probability summation formula, we are having the relation is probability of, here the R notation we are mentioning with union. So A union B is equal to probability of A plus probability of B minus probability of what is a common event between those two elements, intersection of A. Now you can find that. But this one, first you can find the event execution for red element. For red element, we are writing that the probability of A is equal to the desired outcome. The available red balls are 16. Thus we can write in that 16 divided by the total possible outcomes are 50. Similarly, you can write in for the event B. B is for black color. We can pick the black color ball. How many black color balls is available in this box is 22. We are writing that the 22 divided by the total possible outcomes. Next, you can take that what is the common between these two events A intersection B. Here the common element. If there is any common element is there? There is no common element. Why? For the common element, the ball must be red or black. This type of ball is available or not. Here, the common element is must have the both properties. But here there is no common element. That's why the intersection element is 0. Now you can find that so A union B is equal to the 16 divided by 50 plus the 22 divided by 50. The intersection value is 0. This one is the outcome. And I have to pick one ball. The ball is red or black. The probability is this value. 16 plus 22, the value is 38 divided by 50. What is the third one? The third one is neither red nor green. Neither red nor green. Neither red nor green means here the both events are complementary. Here for this case we are assigning the events names. Neither red. Red event you can give to A. For green event you can give that G. He is asking neither red nor green. So you can take in the complement values. A bar intersection G bar is the probability. You can write in this one, probability of A union G whole bar. Already we are on the complement event. According to complement event, we are rewriting this one. The normal event A union G whole value is equal to 1 minus probability of A union G. Just you can find that this event, you can substituting the value in this one, you can obtain the pickup ball neither red or not green value. You can simply finding by using the summation formula. Summation formula is also repeating that. It's the probability of A, already know that. The 16 divided by 50. Next, probability of Z is equal to what are the green balls is available. The totally 12 balls is available. 12 divided by 50. What is the common element? There is no common element. That's why I am putting the 0. That is the probability of A intersection Z is equal to 0. Now substituting this all values in this one. The 1 minus the 16 by 50 plus the 12 by 50 minus 0 element. This one gives that the final value. This is a complete problem regarding to a box is containing the 16 red balls and 22 black balls and 12 green balls. You can picking the ball is what are the conditions we are having is simplifying like this. And every problem in this model we are making the solution in this way. Remaining thing we are discussing next class.